Okay, we're going to solve the next exercise. The exercise is the number 1.24. The area of the Pacific Ocean is 64,186,000 square miles, and its average depth is 12,925 feet. Assume that the weight per unit volume of ocean water is 64 pounds divided by feet to the third power. Determine the mass of the Pacific Ocean, A in slugs and B in kilograms. Well, the first thing that I'm going to do here is that I'm going to write down the information that the problem is given to me. So the area is equal to 64,186,000 miles to the second power. Then I have the depth, which is equal to 12,925 feet. Assume that the weight per unit of volume is equal to 64 pounds divided by feet to the third power. Determine the mass. Alright, there is something that I want to make clear here, and is that I'm not using the same notation that the problem is using, because as you can notice here, the problem is using commas for when it's referring to million and for when it's referring to thousands. So I don't like to use that kind of notation. Why? Because maybe I'll get confused along the exercise and I don't know if I'm talking about decimal numbers or I'm talking about millions or maybe thousands. So for when I use a comma, make sure, or a point, make sure that, or you could be sure that I am talking about decimal numbers. Alright? Now, continue with the exercise. The first thing that we have to analyze here is that I am using some different kind of notation for not different kind of notation, from some different kinds of units systems. So I have right here a mile, here a feet, here a pound, here a feet, and the final answer I have to give it in kilograms. So first I'm going to use customary base units, and for me to do that I gotta transform this value. So I gotta eliminate the mile and transform those into feet. So for me to do that I gotta know some equivalence here, right? So I already know that 1 mile is equal to 5,280 feet. But it is important for me to take into account these two, because then I have to evaluate this division to the second power. And right here I have my first unit conversions. So it is going to be 64,186,000 times, well, actually it doesn't matter, times 5,280 to the second power. So the answer is this one. I'm going to write down the first four significant digits. So 1.789 times 10 to the 15 power. Alright, and I'll have the answer in feet to the second power. Alright, I already have the depth in US customary base units. I already have this value in customary base units. So now that I'm working with the same kind of unit system for all the data that the exercise has given to me, now I can start using some different equations or some different ways for me to solve the exercise. The first thing that I have to notice here is that they are talking about a mass. So we all know that a mass is given by the equation of the density. So the density is equal to a mass divided by a volume, which means that the mass is equal to a density multiplied by a volume. Alright, first I'm going to look for this value. So a volume is equal to an area multiplied by a depth. And that is what I have right here, because you have to analyze that a volume is given in meters to the third power, feet to the third power, everything to the third power. Alright? So an area is to the second power and a depth is just to the 1 power. Alright? So by doing this, I'll have this value copy. I don't know if I've copied the exercise. Right, let me do that again. No, I'm taking the exercise. Let me move this. Now, copy and paste. Multiply it by this one. Copy and paste right here. So the answer is 12, 9, 25. 2.31 2 times 10 to the 19 power. Alright, I have this value. Now I gotta look for this one. A density, as I've just said, is equal to this. But it could be not bad. It could be also like being analyzed by this value. Why is that? Because the first thing that we have to notice here is the word weight. So when every book or when any book is talking about a weight, it is necessarily talking about a force. So weight is a force, and because of Newton's second law, a force is given by a mass multiplied by an acceleration. This acceleration is usually the gravity, because I'm talking about a weight. Alright, so here I have a weight per unit of volume. Alright, so if I divide the force by the acceleration, I'll have the mass. Right? So the same thing goes for the data that the exercise is given. If I divide the force by the acceleration, I'll have the mass, right? Now let me explain this I think that you already understand what I'm trying to say here, but let me explain this more, or make this more like easy to understand. Here I have a force, so this is the same thing as having slugs multiplied by feet divided to seconds to the second power. Alright, and right here I have feet divided by seconds to the second power, right? A mass multiplied by an acceleration is equal to a force. Right? But right here is important for me to know that I have this. But I'm putting this value aside for a moment. And right here I have the gravity, which is an acceleration, feet divided by square seconds. Right? So I could eliminate these ones, and the result will be slugs divided by feet to the third power. So let me do this. I'm going to save this value on the calculator, so if you don't know how to do this, you just have to press shift, then this button, because here you can access to the storage, as you can see in yellow, and then you have to press a letter that's in red. It has to be in red, so maybe the A. Right, so now I can clear this, and when I look for the A, the calculator is going to give me the answer. Alright, now 64 divided by 32.2 is equal to this huge number, and I'm going to save this number. I'm sorry, I'm going to save it on the into the B. Alright, now that I have this, the mass of the ocean will be, and this value, the B value, (1.9875) slugs divided by feet to the third power multiplied by the volume that I've found before. So it is going to be 2.312 times 10 to the 19 power feet to the third power. So the answer will be in slugs, as you can see here. So the answer is A times B. A. Mass in the US customary base units is equal to 4.5968 times 10 to the 19 slugs. And now I gotta transform this value into kilograms for the B section of the exercise. And for me to do this, I gotta know the equivalence between slugs into kilograms. So 1 slug is equal to 14.59 kilograms, and that means that I just gotta multiply this by 14.59. and the answer is for the B section is mass is equal to 6.70 68 times 10 to the 20 power kilograms. And right here, guys, and right here I have the answer. Alright, so that is the way, or that is one way in which this exercise could be solved.